So in this problem we have to, is similar to the previous problem. We have to transform this using the impedance transformation formula, and this into, it will look like element. You have to find the impedance at this, from this, how much impedance this stub is given. So using the impedance transformation formula, the values given such that it gets simplified. So we have this Z equivalent, if Z0 50 and Zn as 40. So this, if we find distance beta L1, then this gives 7 pi, and 10 of 7 pi as we know it's 0. So basically this becomes 0, this becomes 0, and we are left with Zl1 upon Z0, and this will cancel, and we will get Zl1 as Zn1. So basically the value of this transformed element will be 40 ohm. So we can replace this as, if we are looking the impedance, this as an element with 40 ohm resistance. Similarly, we have to find the Zn2, that is to transform the impedance and find how much impedance we are getting. So in this case, we have Zl2 and Z02 same. So this and this is same. So this will cancel obviously, and we are left Zn2 equal to Z02, that is 50. Now we have to find at the intersection what is the total impedance. It will be parallel combination of these two impedances, which we write as 22.22. And next we have to find the total power. For finding that, we require is gamma s and gamma naught. Gamma s, it will be 0 because 50 minus 50, it will be 0. Gamma naught, you have to consider this as a load at this point. The parallel combination is at total minus this is the characteristic impedance, which is the source part. And so the total minus ZL minus Z0 upon ZL plus Z0. But this is the reflection coefficient. And basically, since gamma s is 0, so this part and this part will be 1, 1. And this formula will be reduced to this, and Pn can be calculated as 0.1. Since all the transmission lines are lossless, the total power at the input will be delivered to the load. So the sum of PL1 and PL2 will be delivered. The sum of this power will be equal to the input power. So power, as we know, it is square root RMS voltage square upon the resistance, or V by root R2 square by the impedance. So this will be V square by 2Z, and we have to find the voltage at the intersection. So basically, if we are in these terms and substitute this as the Z total, that is the load impedance, and the intersection power that we have found out, that is the input power, we will get the intersection voltage. In order to find the power delivered to the each load, we just have to substitute these values, and Zn1 as we have found out 40 ohm, and V int 3 square V9. Similarly, you can find for P in load 2, and the sum of this must be equal to the input power, which we had calculated.